Satyabama Institute of Science and Technology.
Hi all, myself Gayathri Sivakumar, Department of Computer Science and Engineering at Satyabama Institute of Science and Technology, deemed to be University. In today's topic, we are going to see one of the most interesting topic, which is nothing but the confusion matrix in machine learning. Without any further delay, let's just jump into the content. Here is the agenda. So first we are going to see an introduction or the definition of what is confusion matrix, followed by the need or the purpose or the uses of what is the purpose of using this confusion matrix. Next is a pictorial representation of how a confusion matrix is going to be, and followed by a problem of how to solve some various particular different parameters on a given set of test data, and last is nothing but the real-time applications of confusion matrix in machine learning. So here is the introduction to confusion matrix. Confusion matrix is nothing but it is n into n matrix, where n is nothing but the rows and another n is going to be column. Okay, so it is nothing but it is n into n matrix, which is mainly used for performance evaluation tool in the machine learning technique to provide, or it represents for the basic needs or the accuracy of the classification model in a set of test data, where n is nothing but it is going to be the total number of target classes. And here what does this matrix compasses? It actually compares the actual target value with the predicted machine learning model. So by using this matrix, confusion matrix in machine learning, we are going to display true positive, true negative, false positive and false negative predicted by the classification model on a given set data. So here this is nothing but the pictorial representation of a matrix, where this is my predicted and this is going to be my actual value. Okay, so here TP stands for true positive and TN stands for true negative, false positive FP and false negative FN. Okay, where this TP is nothing but it actually gives a total count of both predicted and the actual values is going to be positive. Okay, since both are true, it must be positive. And the next is my true negative. This actually counts both the predictions and the actual values must be negative. Why? Because it is false, so both the predictions must be negative. And coming to the next is false negative. It actually counts only the actual value but not the predictions. Okay, so that means the total counts having no predictions but it has only actual value. But FP, it is quite opposite of FN, where this will predict the predicted values but not the actual values. This is how the representation of a normal confusion matrix in machine learning model will be. And here our matrix is basically divided into two dimensions. The first one is going to be my predicted value and the next is going to be my actual value, along with the total number of predictions, how much ever we have given. Okay, predicted is nothing but it is going to be the actual value which is being predicted by the machine learning model, and actual values are the nothing but it is the true value which is given for the classification. This is the need for the confusion matrix and machine learning. So we will learn about the process or the purpose of what is machine learning in confusion matrix. Okay, it basically evaluates the performance in a given classification model. In machine learning, you can be having different models like classification, KNN, and some of your most of the models will be there, but here this confusion matrix is specifically used only with the classification model, that is your classifier. Okay, so it evaluates the performance in the classification model when they need some predictions and tells how good our classification model is going to be. And next is the major impact of this confusion matrices is not only tells whether the error is there or not, but then it also finds and tells what type of error, like either type 1 error or type 2 error. And last but not the least, with the help of this confusion matrix, I told you quite before, we can calculate different parameters by using this machine learning model in the classifier. Like you can know different parameters like your accuracy, precision, prevalence, recall, FN score, etc. And here I am coming to the calculation problem. See, suppose we have to give a problem where we have to predict the results of a given, for example, a person is admitted in a hospital for a disease. Okay, we have to predict that whether the person is having disease or not a disease. Okay, so whether a person has disease or not. So here is my predicted and actual values, where n is the total number. Okay, so Tn, that is true negative, is going to be 65 and true positive is going to be 24. Again, false positive is 3 and false negative is 8. This is nothing but the count. So 65 plus 8 is going to be 73 and 3 plus 24 is 27. And this is the no count and yes count. This is my predicted no count and yes count is going to be 68 and 32. Okay, n is equal to 100 is nothing but the total number, like 65, 24, 8 plus 3 is going to be my 100. Okay, now from the given above example, see here, the table has two classifiers where there are two predictions. One can be yes and the other can be no. Yes determines the patient has the disease, and obviously no determines the patient does not have any disease, right? So here the classifier has total number of 100 predictions, and out of this 100 predictions, we have 89 are true predictions. See, 89 means 65 plus 24 is going to be my 89. These true is nothing but Tn plus Tp is going to be my 89 are true predictions, and among that 11, that is 8 plus 3 is going to be my incorrect predictions. But here the model has given yes for 32 times, but see, this is the actual count, but they have predicted. Okay, always the actual and the predicted may vary one or less, right? So the my prediction S was only 32 and predicted no is going to be 68. With this we are going to find different parameters by using this confusion matrix. First one is my classification accuracy. This tells how often the model is going to predict the correct output. So the formula for this accuracy is Tn plus Tp. Why? Because it is going to predict the correct output. So obviously it must be true only, right? So true negative plus true positive divided by the total number, that is true negative, true positive, false negative and false positive. So 65 plus 24 divided by 65 plus 3 plus 8 plus 27, that is going to be my 39.36. Okay, the next is nothing but my misclassification rate, that is also called as the error rate. This is quite opposite of this accuracy. This defines how often the model will predict the wrong prediction. So wrong means it is going to be false. So false positive plus false negative divided by total number. You can get the data from the previous slide. Okay, so 3 plus 8 divided by, this is going to be my misclassification or the error rate. And the next is going to be my precision, where it defines the number of correct outputs. Correct output means it is going to be both are true. So true positive out of all the positive classes means true positive and false negative, that is predicted correctly by the classification model. Okay. So Tp divided by Tp plus Fp, that is nothing but 24 divided by 27 plus 3, is going to be my 3.88%. Okay, and the next is my recall. It defines out of all the positive classes, all the positive, total positive means if it is false positive, it is not totally positive. So here we have included only Tp divided by, however the predicted correctly, the recall must be high as possible. So predicted correctly means it must be true positive plus false negative. So that is equal to 24 divided by 27 plus 8, that is 8.88. And the next is, we are going to find how the F1 score will be calculated. F1 score, it helps out to evaluate both the recall and precision at the same time. Both must be calculated at the same time, where there is a condition for this F1 score. The F1 score is maximum only if and only if my recall is equal to the precision. So obviously it is not equal. See, recall value is going to be 8.8, but whereas precision value is 3.8. With that, we are going to find the F1 score is maximum. So the formula for F1 score is 2 into recall into precision divided by recall plus precision. So here 2 into recall value is 8.8 into 3.8 divided by recall is 8.8 and precision is going to be 3.8. So with this, the answer is going to be 11.64. And the next is my prevalence. Prevalence means it actually indicates how many true or positive cases actually occurred. True or positive means both must be there. So though it is going to be true positive obviously. So true positive actually occurred out of all the observations, means like your true positive, true negative, false positive and false negative also. So TP divided by TP plus TN, FP plus FN. So which is going to be my 24 divided by total number of observations, that is going to be 77. And last is nothing but my applications or the real-time applications which I have been implementing in the confusion matrix. So first is my medical diagnosis. As obviously we have seen in the before example, we are predicting whether a person is diagnosed by a disease or not. So this is basically used in most of your hospitals. With this confusion matrix has been used like a medical diagnosis to identify whether a person has true, false, positive or negative disease or not. Okay. And next is my fraud detection to see some of your most of your fraud detections to verify whether it is true or not. This is going to detect. And the next is sentiment analysis, means for example, you have some real-time examples like when a car is going, the driver is feeling drowsy, automatically an alarm or alert will be coming, right? That is called a sentiment analysis. And the last is my image recognition. This can be possible in both ML and also AI also. That is all about your confusion matrix in machine learning. Thanks for watching this video.